Good afternoon. Welcome to NPTEL project on econometric modeling. Today, we will discuss the concept bivariate econometric modeling. So, it is a statistical tool which deals with the relationship between two variables only. In the last class, we have discussed the entire structure of data analysis, that is univariate modeling, bivariate modeling and multivariate modeling. Particularly in the last class, we have discussed the entire structure of univariate modeling, that is with respect to central tendency, dispersion, skewness and kurtosis. The main objective behind univariate modeling is that we have to describe the features of a particular variable, that is with respect to its average, mid value, frequency distributions and its variability within the system. However, in the real world, lots of variables are integrated with other variables. We cannot generalize a particular problem, or we cannot discuss a particular problem with respect to a single variable. The analysis of univariate modeling is very essential, or it is the essential condition, or you can say necessary condition for bivariate modeling and multivariate modeling. So, we are here to know details about bivariate modeling. It is the game between two variables at a time. So, let me take a case. What is exactly the concept of bivariate econometric modeling? Bivariate econometric modeling, I will call it here BEM, bivariate econometric modeling. Okay. Bivariate econometric modeling basically deals with two problems: association and causality. Okay. Association and causality. So, we have two variables in a systems. In a bivariate econometric modeling, our objective is to know the association between two variables, and second objective is to know the cause and effect relationship between the two variables. Some of the problems you may not need to know the cause and effect relationship, and some of the cases you are also not very much interested about the association between two variables. It is a very interesting history behind the movement from univariate to bivariate and bivariate to multivariate. In this particular bivariate framework, again there is a history. So, the history is that the movement from association to causality, both are somewhat similar in nature, but causality is a little bit much higher and much better than the association, because causality is the part of causality is the generalized concept and association is the part of causality. So, now in this particular models here, bivariate econometric modeling, we have two basic objectives, association and causality. So, we have altogether three forms of technique. So, in the association, we have two different techniques called as a covariance, and here we have correlation. and in the case of causality we have a technique called as regression. So, in the bivariate framework we have two different games, one is association between two variables and another is cause and effect relationship between two variables. So, far as association is concerned, we can apply covariance and we can apply correlation. Between the two, correlation is much better and much advanced technique than covariance. We will discuss how it is advanced and how it is much better than covariance. However, the origin of bivariate econometric modeling is covariance. Correlation is an extension of covariance. Similarly, regression is also an extension of correlation. So, the movement is from covariance to correlation, then correlation to regression. So, we will discuss here first what is all about the covariance, then we like to know what is correlation, then we have to proceed for regression. The moment you will enter to the regression, then that is the root point of real econometric modeling. Whatever components we are discussing now, it is just supporting components to econometric modeling, and it is very essential unless you know the concept structure of univariate modeling, bivariate modeling and its limitation or advantages, you cannot proceed further econometric modeling with a multivariate framework. So, now we will start with the issue of the bivariate game, that too covariance analysis. So, what is all about this covariance analysis? Let me explain here covariance analysis. So, let us take a case here, two variables say x 1 which represents the component x 1 1, x 1 2 up to x 1 n, all right, and another variables we have x 2, x 2 1, x 2 2 up to x 2 n, all right. So, now the moment you will say bivariate econometric modeling, your boundary must be in between two variables, that is first condition, and second condition is that since we have or we like to trace the association between two variables, the sufficient condition is that the sample informations must be uniform, must be similar. For instance, if x 1 contains n number of sample points, then x 2 must have n number of points. If x 1 is n minus 1 and x 2 is n or vice versa, then the system is inconsistent. To apply covariance technique or correlation technique or regression technique, the first prime requirement is that you must have uniform sample distribution. So, the observation for both the variable should be similar and unique. If the observations are not similar or unique, the system itself is inconsistent. So, now with the inconsistent system you cannot apply none of the techniques, neither correlations nor you can say regression or covariance. So, now the starting point is here is that the classification of variables. In the last class I have discussed variable classification and that too in a multivariate modeling and that too entire structure of data analysis. When the system is univariate, then the classification of variable is not at all matter, because there is only one variables. We have no clue to make the classification. the moment you enter to the bivariate econometric modeling, you must have the problem about classification of variables. In a bivariate framework, classification of variable sometimes important, sometimes may not important, and it depends upon the technique which we use in the particular process. If we handle the technique covariance or correlation, then the classification of variables are not at all important. However, if you go for regression technique, then classification of variable is very important. Until unless you classify the variable, then you cannot apply the regression technique. So, that means what is all about this classification? Classification here we mean the dependent classification and independent classification, which we have discussed earlier in detail. Here the issue is the classification of variables. So, now in the case of covariance and correlations, so we need not require any classification. So, no classification of variables, no classification of variables, okay? No classification of variables, that too dependent and independent. However, in the case of regression, you need to have classification of, variables, that is with respect to dependent structure and independent structures. Here in the case of covariance, you need not require anything to describe the classification of dependent variable and independent variables. So, before we go for this regression or all about this dependent structure and independent structure, it is better we first know the exact issue of covariance, then we have to move correlation and regression. So, question is what is covariance? For this particular system, x 1 contains n items, x 2 contains n items, then covariance is represented as COV upon x 1 and x 2 represents summation x minus x bar into x 1 minus x 1 bar into x 2 minus x 2 bar I upon 1 to n divided by n. So, this is the standard formula we like to apply to get the covariance. So, covariance is simply represented as sum of x deviation and x 1 deviation and x 2 deviation, and it is total number of observation. Here n represents total number of observations, and x 1 represents a particular variable, first variables, okay, and x 2 represents second variables, all right. Then third x 1 bar represents mean of x 1 variables. Okay. Similarly, x 2 bar represents mean of second variables, that is x 2. Okay. So, now I is the class size or class intervals. So, let me write in different way. So, now for x 1 and x 2, covariance is equal to summation x 1 minus x 1 bar into x 2 minus x 2 bars, all right, I equal to 1 to n divided by n, all right. So, now I can write this structure into summation simply x 1 and x 2 divided by n, and for simplicity you can write like this: first x and y, then covariance of x y equal to summation x y divided by n. Okay. So, n is the number of observations. However, for x and y, x y, or if you put x 1 and x 2, then obviously the observation is n 1 and n 2. So, these are the observations. So, now I have already mentioned that for covariance the essential condition is that sample observation must be same. If it is same or uniform, then you can proceed further. So, that means your n 1 must be equal to n 2. So, that means n 1 must be equal to n 2. If n 1 not equal to n 2, then the system itself is inconsistent. So, now you cannot apply here covariance if the sample observations are completely different. So, in order to have sample observation different, if sample observation different, then you have to adjust the systems. So, that is with respect to simplicity of this picture. So, now to highlight all these things, you need to have examples. Let us take a case of 2 examples here, x and y. All right, x here minus 10, minus 5, 0, 5 and 10. All right. So, now here you have 5, 9, 7, 11, then 13. All right. So, now you need to calculate covariance. So, covariance is simply the summation of x minus x bar and y minus y bar divided by total number of observations. So, that means we like to know what is sum of x, okay, what is sum of y, then we like to know what is x bar, okay, what is y bar. X bar is nothing but sum x by n and y bar is nothing but sum y divided by n. So, corresponding x bar and y bar, we must have the component x minus x bar and y minus y bars. All right. So, now x minus x bar, so that means minus 10 here minus this x bar. So, what is x bar here? So, now sum of x is equal to here 0, okay. Sum of y is here equal to 45. All right. So, now corresponding to x bar, so sum of x equal to 0 divided by number of observations. So, number of observation is here n equal to 5 and this is also n equal to 5. So, 0 by 5 is equal to 0 and summation y by n is nothing but 45 by 5, it is equal to 9. So, obviously, it is x minus x bar means it is otherwise known as x minus 0 and it is nothing but y minus 9. All right. So, now the corresponding components is nothing but minus 10, then minus 5, then 0, then 5, then 10. So, in the case of y, it is minus 4, then 0, then it is minus 2, then it is 2, it is 4. Okay. So, now it is this is the sum of x and sum of y. Okay. So, we need to have summation x y, summation x y, sorry, x into y, then we have to get summation x y. So, x y means here small x y, that is nothing but x minus x bar into y minus y bars. Okay. So, this is the sum case. So, x y is nothing but minus 10 into minus 4. So, it is 40, then this is 0, this is 0, this is 10, this is 40. So, sum of x y is equal to simply 90. Okay. So, now I will summarize it. So, now you remember here sum of we have two variables, x variables and y variables. let us you start with the univariate structures. Univariate structure. Let us we start with the component univariate structure. So, what is univariate structure? Now, you like to know what is x bar, what is y bar, what is this is means arithmetic mean, then what is median, what is mode, what is skewness, similarly in the case of x and in the case of y. Okay. So, now you know median is nothing but middle most value of the sequence. So, if you arrange it proper sequence, then obviously in the first case the median structure is here. So, 0. So, in the second case you have to arrange it ascending order, and if you apply the technique, then obviously the size of median is 9 also. So, now in the case of x median is 0 and in the case of y it is 9. So, to get mod equal to 3 median minus 2 mean. So, accordingly you will fill the gap of mod and you can fill the gap of mod, and for skewness is equal to mean minus mod, okay, or mean minus mod by standard deviation, okay, standard deviation. So, that we have to calculate this skewness component, all right. So, this is what the univariate structure is concerned. Okay. So, now before you explaining the issue of covariance, you must have a clear cut understanding about univariate statistics, because the univariate output will give you the path for bivariate structure. So, bivariate results depends upon the univariate results. So, you must have a complete information about univariate statistics, then you have to proceed further you can say bivariate structure. So, now coming to bivariate structures, so we need to know what is summation x y. So, summation x y is here 90, okay. Summation x y is 90. This summation x y is small x y, not capital X y. I like to clarify one thing here. So, x is a deviations which represents x minus x bar, and y is also deviation which represents y minus y bar. So, obviously, sum of x minus x bar into y minus y bar is nothing but summation x y. So, now covariance upon x y represents summation x y by n. So, that is nothing but 90 divided by number of observation is 5. So, which is nothing but equal to 10. Okay. So, now this structure is equal to this structure will give you the concept of you can say covariance. So, covariance is nothing but it is not 10, it is 18. Okay. So, so the value of covariance is 18. So, that means the association between x and y is nothing but 18. So, now we have complete information about univariate structure and complete information about the bivariate structure. So, that means, so we like to know what is the x 1 in the system or x in the systems, and what is the nature of y in the systems, and we like to know what is the association between the two. So, now that is possible under the structure of covariance. So, now with the help of the covariance, we like to know degree of associations, but sometimes there is a problem. That is how it is another technique called as a correlations. So, now one thing is very clear here, because covariance will give you similar results, correlation also give you similar results, because the objective of correlation and covariance is that it measures the degree of association between two variables. So, now once you calculate the degree of association through covariance, then correlation is not at all matters, or if you calculate through correlation, then covariance is not matters. But there is sometimes issue The issue is that correlation is much better technique, much advanced technique than the covariance. Why? Because some of the cases covariance has limitation. For instance, if you go for comparative analysis, last class we have discussed the issue between the US dollar and Japanese yen. So, now when you will go for comparative analysis, then obviously unit of measurement is always matter. So, in that case the relative measure sometimes is much handy for the analysis or for a particular problem. So, like in the case of univariate analysis, covariance is much better than standard deviation. So, in the case of bivariate modeling, correlation is much better than the covariance, because it is unitless measurement. So, now we like to know what is the structure and setup of correlations. So, let me highlight here what is the entire structure of correlation here. So, correlation, so for x and y, for x and y, where x contains x 1 up to x n and y contains y 1, y 2, y n, all right. So, now we like to know what is the structure of correlation. So, now correlation is nothing but we will write COR upon x and y. So, then correlation of x y is nothing but covariance of x and y divided by sigma x into sigma y. Okay. So, what is sigma x and what is sigma y, that is the issue here. So, now sometimes it is represented as a sigma x y by sigma x and sigma y. Sigma where sigma x stands for standard deviation of x, and sigma y represents standard deviation of y, okay, and sigma x y represents covariance of x and y. So, sigma x sigma y is the product of univariate modeling and sigma x y is the product of bivariate modeling. So, now correlation is nothing but the ratio between covariance of x y by standard deviation of x and standard deviation of y. So, put it in explicit format, then the covariance correlation of x y is nothing but summation x minus x bar, covariance between x minus x bar between x minus x bar into y minus y bar divided by summation x minus x bar whole square into summation y minus y bar whole squares. Okay. So, now the issue is here. So, you like to know what is x bar here. X bar is the mean of x, y bar is the mean of y, all right, and n represents number of observations. Okay. So, now n does not matter here, because upper side n and lower side n is cancelled. So, now if I will simplify the structure, then it is simply represented as a summation x y by summation x squares and summation y squares. Okay. So, now x is nothing but x minus x bar and y is nothing but y minus y bar, both are in deviation format. Okay. So, now further simplicity, the correlation coefficient can be calculated as n summation x y minus summation x into summation y divided by n summation x square minus sum x whole square into n summation y squares minus some y whole squares, okay, whole to the power 1 by 2. Okay. So, this is the complete structure of correlations. So, now the interesting issue is here the value and nature of correlations. So, now before we proceed to put it in a real example format, we like to know what is the features and speciality of correlation. The feature and speciality of correlation is that first the value of correlation coefficient, which usually denoted as a rho. Okay. So, minus 1 less than 1 less than equal to minus 1 less than minus 1 less than rho less than equal to 1. So, that means, the value of correlation coefficient lies between minus 1 to plus 1. So, this is the standard technique, mathematically there is a proof. So, it is always true that the value of correlation coefficient should be in between minus 1 to plus 1s. So, if it is minus value, then it is represented as a negative correlation, and if it is towards plus, then it is called as a positive correlations. All right. So, now second property is that correlation coefficient is symmetric in nature, r x y is equal to r y x. Okay. Then covariance of x y, covariance of x y is sometimes represented as a covariance of u and v. U and v is treated as a another set of variables. That means, the most important trick is that correlation coefficient is independent of change of origin and scale. For instance, if you will take a case here, u equal to x minus a by h and v equal to y minus b by k, then when you will simplify this, then you will get r u v. Whatever r u v you will get it, and same structure you will get it through r x y. Sometimes this origin and scale are very important when you will go for, you can say, higher order problem and complex problem. So, it is very important for that particular angles. So, now before proceeding further, so I like to highlight here one thing, that one of the condition of this correlation is that the variable structure or sample observations must be uniform for both x and y. So, let me here take an example. So, how this example can be applied to calculate the correlation coefficient. Okay. So, now we can cite this same example. In fact, we can cite this same example here. So, the example is here, x represents minus 10, minus 5, 0, 5, 10, and y represents 5, 9, 7, 11, 13. All right. So, we need to calculate correlation coefficient. So, as usual, you must have some univariate statistics first, that is descriptive situation. So, the descriptive will come automatically. Let me highlight here. So, this is you need summation x, okay, you need summation y. So, now univariate statistic structure, you like to know what is summation x. Okay. So, what is summation y? Summation x is here 0 and summation y is here 45. Okay. So, corresponding to summation x, we have x bar, which is nothing but summation x by n, and n represents here 5. So, obviously, x bar is equal to summation x by n, that is nothing but 0 by 5 and which is equal to 0. Okay. So, now summation y case, it is y bar is equal to again 45 by 5 it is equal to 9. Okay. So, now this particular information is very much required for further analysis. So, now we need to have x minus x bar and y minus y bar, all right. So, now I am directly writing here. So, minus 10, minus 5, 0, 5, 10, then here minus 4, 0, 2, minus 2, 2, then 4. Okay. So, then this represents x component small x and this represents small y, all right. So, now small x and small y. So, we need to have information about small x square and we need to have information about small y squares and you need to have information about small x into small x y. So, now x square represents here 100, then 25, 0, then 25 and 100. Okay. So, now then y square is equal to here 16, 0, then 4, then 4, then 16. Okay. So, now we like to know what is some x square. So, now come down to here some x square and some y square. Okay. So, now then we must have summation x y. Okay. So, now for summation x y, so this is minus 10 into minus 4, this is 40, then 5 minus 5 into 0 0, then 0 minus 2 0, then 5 into 2 10, then 10 into 4 it is 40. Okay. So, now we have, if we simplify further, then summation x square is equal to 250, then summation y square is 40 and summation x y is nothing but 90. Okay. So, this is the sum total is here 250, 40 and 90. Okay. So, now we have to know what is the value of correlation coefficient. So, now having such information here, so we like to know the correlation statistics. So, now correlation correlation for x y is nothing but covariance of x y into sigma x into sigma y. Okay. So, now sigma x is equal to summation x square by n and sigma y is equal to summation y square by n, all right. So, now the moment you will put it here, then obviously correlation coefficient is equal to covariance of x y, which is nothing but summation x y by n, okay, divided by sigma x and sigma y, okay, sigma x and sigma y upon 1 by n, all right. So, now we like to know what is covariance of x y. Covariance of x y is nothing but summation x y by n, which is nothing but 90 by 5. So, it will be around 18. Okay. So, now we have already sigma x equal to summation x square 250 by 5 square root and sigma y is equal to 40 by 5 into square root, all right. So, now the structure of correlation coefficient is that r equal to 90 by square root of 250 and square root of 40. So, n automatically cancelled. So, now which is around 0.9. Okay. But one thing is very clear here, we know the correlation coefficient is always between -1 and +1, and the nature of correlation depends upon the movement of covariance. The reason is that standard deviation of x must be always positive, because it is the square root of variance. Similarly, standard deviation of y is also always positive. So, the value of correlation, whether it is negative or positive, depends upon the value of covariance. Now, if the covariance is negative, then we must have negative correlation, and if the value of covariance is positive, then we must have positive correlation. Okay. So, now with these structures we can cite here. So, the essential condition for this structure is that sigma x is always greater than 0, sigma y is always greater than 0, and sigma x y is either greater than or less than equal to 0. Sigma x sometimes can be also 0. So, that is why the condition is that sigma x greater than equal to 0, sigma y greater than equal to 0, and sigma x y is greater than equal to 0. Okay. So, now in order for better you can say simplicity, so we like to know the nature of the correlation coefficient. So, now I will explain here the detailed structure of correlation. Correlation basically has 3 different format. Okay. It is basically 3 different format. First is the first format represent the simple correlation, then second is called as a partial correlation, third is called as a multiple correlation. Okay. So, correlation again can be linear and can be non-linear. Okay. Then correlation can be positive, can be negative, or can be 0. Okay. Can be 0. So, correlation, the basic framework is simple correlation, partial correlation, and multiple correlation. It can be linear in nature, it can be non-linear in nature. It can be positive, it can be negative. Sometimes the value of correlation coefficient can be also 0. If the value of correlation coefficient equal to 0, then there is no association between these two variables. For instance, we have a relationship between pen and paper, but we may not have a relationship between this pen and chair, because we do not have any link between pen and chair. So, one interesting issue is here, that before we entering to the correlation statistic, there must be sound theory behind it, because anything you will try to integrate, you will get some value, because it is all about mathematical calculation. But the interpretation, the utility, the usefulness depends upon its theory only. Theory will give you support, or you can say sound structure, so that you can establish the problem setup. If there is no theory behind the correlation approach, then this term is called as a simply nonsense correlation. It is sometimes called as a nonsense correlations. Okay. So, now before we go into detailed structure about that issue, let me explain how is the accurate structure here. All right. So, now within the particular setup, this particular structure is called as a multivariate framework. This is called as a multivariate framework. Okay. It cannot be with two variables again, it is with respect to more than two variables, but simple correlation is a bivariate game. Simple correlation is a bivariate game. However, partial and multiple correlation is a multivariate game. So, here we will not discuss about this partial correlation coefficient and multiple correlation coefficient, because we will discuss details when we will go for multivariate modeling. So, now if we integrate all these structures here, then we have various forms. Let me explain here what are these forms. So, I will give you indication. This is one way we can represent the correlation coefficient. Here x information and y information. So, now one shape of correlation structure is like this. Okay. So, now I will just draw this. So, this particular setup is called as a positive linear correlation. Okay. Positive linear correlation. This is case 1. This is case 1, positive linear correlations. Okay. Case 2, 0, x and y. So, now the structure may be like this. I am just highlighting what are the possibilities under the correlation modeling. So, now this particular structure is called as a negative linear correlation, negative linear correlations. Okay. We have, this is situation like case 2, all right. This is situation of case 2. I will put another structure here. Okay. So, I will represent like this 0 x y, then the structure may be like this. I will put like this, then I will join like this. Okay. So, this is called as a positive non-linear correlation. Okay. So, this is case 3. So, case 3 is a positive non-linear correlation. Okay. Then I will represent another case here. Okay. So, now that case is like this. Then I will draw like this. Okay. So, this x and y. So, this particular structure is called as a negative non-linear correlation, negative non-linear correlation. So, now case 4 is negative non-linear correlation, negative non-linear correlation. So, now we have 4 different games. So, first is positive linear correlation, negative linear correlation, positive non-linear correlation, negative non-linear correlation. So, that means altogether 4 different shapes of correlation we can find. If the structure is in between 0 to minus 1 and 0 to plus 1. If the structure or the value of correlation coefficient exactly at that 0 level, that means the structure is completely different, which we call it 0 correlations. So, that means there is another case where we have no correlation between two variables. So, that means the setup is like this. So, we have no relationship between these two variables. So, that is why you must have sound logic, sound theory, sound structure, then you can apply the correlation technique or covariance technique. Without any theory, logic and structure, if you will apply correlation coefficient, then obviously sometimes either you may get 0 correlation or you may get simply nonsense correlation. Nonsense correlation means the value may not be equal to 0, but it does not support any theory. For examples, if I will just plot one side, this room number of chairs are there, first room number of chairs 10, second room number of chairs is 20, third room number of chairs is 40. Then first room the number of availability of pen is 5, number of second room number of pen is available 20, third number of pen is 40. Then obviously, so I do not find any theory between number of chairs in particular structure and number of pens in another particular structure, where we will get the correlation. So, now correlation can be positive correlation, can be negative correlation, that is with linear structure and that is with non-linear structure, and in between there may be the case called as a 0 correlation. So, this is the entire setup of the structure of correlation. So, now the correlation is very important tool for bivariate econometric modeling, especially it is the middle path in between covariance and regressions. It is much better than covariance and less better than the regression. The advantage of correlation is that it brings the degree of association between these two variables. Since we have already mentioned the value of correlation coefficient is in between -1 and +1, then obviously the nature of association will be very, you can say, divergent, also interesting. If the value of correlation is exactly 1, then it is called as a perfect positive correlation. If the value of correlation is exactly -1, then it is called as a perfectly negative correlation. If it is very close to -1, then it is highly correlated, negatively correlated correlation. If it is very close to +1, then it is called as a highly positive correlation. However, if it is very close to in between like this, so the structure is this is -1 and this is +1. Okay. So, this is 0. So, now if I will say here point minus 0.8 and this is here 0.8, then if this is the range, then this is called as a high correlation, and this is also high correlation, high negative correlation, and this is high positive correlation. So, now if it is in between 4 to you can say 6, then it is called as a moderate correlation. It may be moderate positive, it may be moderate negative. Okay. So, now if the value of correlation less than 2, you can say 4, 3, or you can say very close to 0, then it is called as a very low correlations. So, now the association of the two variables can be very strong if the value of correlation is very high. If the value of correlation is low, then the association is also very low. So, now this is very interesting component and very useful for multivariate technique, and it is you can say opponent regression technique. However, the essential part of this bivariate modeling is that you must have a thorough knowledge and complete information about the univariate modeling. Until unless you have a complete information, complete setup, you cannot handle the game of correlation. So, now it is not possible for us to discuss the detail about regression modeling here, again within the setup of bivariate modeling, which we will discuss in the next class. With this, we can conclude this session. Thank you very much. Have a nice day.